Hi everyone. So today we're going to start our next unit on radicals and rational exponents. So we're going to focus today on what exactly is a radical, what does it mean, what's the difference between an odd radical and an even radical, and what can and we can't take radicals or roots of, and what are the different parts. Okay, so by the end of today, we're going to be able to find the nth root of a rational number and simplify and evaluate expressions involving roots and some exponents. And mainly, that sounds hard, but you'll be fine. You got this. All right, so there's different parts. You have the index, which is the degree of the root. In other words, it tells us what root are we taking. You have your radical symbol, which looks like this. It looks like a little division sign with a little shelf. And n is the index. So the index is this guy. And again, that tells us what root to take. Now, if there's no index, it's assumed to be square root. Okay? And the radicand is the number underneath the radical symbol. So that's this right here. And that's the radicand. And that radicand can be nice perfect squares or perfect cubes, and variables and exponents to fractions and decimals. So it pretty much can be anything underneath the radical sign. So here's a definition, and I'm not a real big fan of this definition because it really sounds a lot more complicated than it actually is. It says the nth root. If a to the n is equal to b, and a and b are real numbers, and n is a positive integer, then a is the nth root of b. So what exactly does that mean? Well, let's say a is 5 and n is squared. Okay, so a is 5 and n is 2. Let's just make a little notation that. And that means our answer is 25. Let's call that b. Okay, so then it says, then a is the nth root of b. So that means that 5 is the square root of 25. That makes more sense. Okay. Now there's two kind of classifications. You got an odds and you got evens. So we split them based on whether you're odd or even. Okay. So if your root is odd, if the index is odd, okay, so this is the index. If you're taking an odd root, there's only one answer. Okay, there's one real nth root, so one answer to the problem. Denoted as radical of the nth root of b. So that means if I wanted to take the cube root of 8, that's 2. Period. That's it. If you take the cube root of, let's say, negative 27, the answer is negative 3. No plus or minus. No multiple answers. There's only one answer. You can take the root of a negative number, a cube root of a negative number. You can take a cube root of a positive number, and your answer is just one answer. And that's for every odd root. So you're talking about cube roots, fifth roots, seventh roots, and so on. But if your n is even and your number underneath b is positive, there are two real nth roots of b. So that means that your radicand has to be a positive number, and that there are two possible solutions. The positive root is called the principal root, and the symbol is the nth root of b. And the negative root is the opposite, or the negative nth root of b. If n is negative, there's no real nth root of b. Okay, so that means that if you're going to take the fourth root, let's say of 81, which is 3, you're going to get plus or minus 3. Okay. If it just says positive fourth root of 81, your answer is 3. Negative fourth root of 81, your answer is negative 3. Okay. If I want both, I'm going to put a little plus and minus sign there. But if I wanted the square root of negative 4, we know that's I, but we're only dealing with real numbers, so we would say no solution here. So our answers are only in the real numbers. We're no i's in any of our problems now. Okay, so let's find some answers. What is the cube root of the following? Now, I don't know about you, but I don't know all the cube roots and fourth roots and fifth roots and stuff like that. So I may need some help with my calculator. Oh, let's see if it's going to shut off. Okay, whew, it didn't. All right, sometimes it shuts off on me. All right, so if I wanted the cube root of 0.008, I'm going to go to math. I'm going to go to number 4, which is cube root. I'm going to put 0.008, and I'm going to get 0.2. There's only one solution because 8 is positive, the 0.008 is positive. That's it. One answer. Cube roots, one answer. Okay, so if I wanted the cube root of negative 1,000, math, cube root, negative 1,000, it's going to tell me negative 10. That's it. Okay, now 1 over 27. Now here's what you're going to do. You're going to do each one. You're going to do the top and you're going to do the bottom. That's how we do fractions. So the cube root of 1 is 1. The cube root of 27. So again, if you don't know, use your calculator. Don't write, I don't know. Okay, you have technology, use it. So this is 3. So 1 over 3. Okay, all right, so let's talk about fourth roots. What number times itself 4 times gives me 1, not just 1. Now, fourth roots. So we got 1 and negative 1. Negative 0.0. The minute I see negative, there's no solution. Because you're doing a fourth root, which is an even, you cannot take an even root of a negative number. Okay, fourth root of 16. Well, I don't know what the fourth root of 16. So in our calculator, you would put 4, math, x root, 16. 2. Fourth root of 81, which I said earlier was 3. Plus and minus because we're doing all the possible roots. Okay, let's do one more. The fifth root of 0 is 0. One answer because I'm doing an odd root. Fifth root of negative 1. Well, that's negative 1. Again, we can do odds of negatives. Fifth root of 32, I don't know. 5, math, x root, 32. Enter. That's 2. And again, one answer. Okay. All right, so let's put this on the side for a moment. Let's come here. All right, which of the following is a real number root? In other words, which one of these can we find the solution of and which ones can't we? Now remember, odds we can take the negative root of a negative numbers, even roots we can't. That's what I want to know. Is it an odd root or an even root? And this would be yes, and that would be negative 3. This would be no, because it's an even root and negative underneath. Negative 7, okay, well, isn't that the square root of 49? Which is 7, so it's yes. No. Can't take the square root of a negative number. Okay, so the first one's yes, it's negative 3. The second one's no, because we can't take the fourth root of a negative number. The next one's yes, because we square negative 7. And the last one's no, because we can't take the square root of a negative 49. Okay, now when we come to simplifying radical expressions, what we want to do is we want to have a perfect root. Okay, love perfects. We're going to try and keep it a perfect root. Okay, that's what we want to do. So we want to simplify it. Okay, so what we're going to want to do is find out square roots. Okay, so I separate this to the square root of 16 and the square root of, well, let's not separate it. We haven't done that yet. Can we make 16 something that's squared? Well, yeah, that's 4 squared. Can we make 8 x to the 8th something squared? Yeah. Well, let's see. What would be the square root of x to the 8th? Well, wouldn't that be 4 groups of 2? Or x to the 4th? No, wait, that's not right. X to the 4th? Something like that. Okay, so 4 squared, so this is going to be 4 x to the 4th. Okay. All right, let's try the square root of 81. Well, we know that's 9. Okay, so this is x to the 4th. Well, what times itself gives you x to the 4th? Oh, that's x squared. How do I know? We add exponents, right? So we want to add the exact same thing. Okay, let's try this one. Okay, so cube roots. I want to know how many times something times itself 3 times gives us like 8 to the 6th. Okay, so here's a 6a's. Okay, that's all underneath the square root sign. I'm just looking at the a's. So I want to have what times itself 3 times. So that means I need a group of 3. And here's another group of 3. So the cube root of a to the 6th is a squared. And then we have our b's. There are 9 b's. Okay, so remember, cube root, I want a group of 3 because that multiplies by itself 3 times. So I have 1, 2, 3 groups of 3s, so b to the 3rd. That's your answer. Okay, let's try another one. Here I have 12s, 12 a's. Okay, I want a group of 3. How many groups of 3 are there in 12? Well, there's 4. How many groups of 3 are there in 15? B to the 5th. Okay. All right, let's try this one. How many groups of 4 are there in 8? How many groups of 4 are there in 12? How many groups of 4 are there in 12? How many groups of 4 are in 16? There we go. So we're going to look at a shortcut in this coming up, but we get the idea that it's like how many groups of the index are underneath the radical. All right, let me know if, let's make sure we got this so far, guys. All right, so we understand the definition. We have odd roots and even roots. Odd roots, we can take negatives, roots of negative numbers, but there's only one solution. That's it for either a positive number or a negative underneath a odd root. If it's an even root, first of all, we can only take even roots of positive numbers, and there's always 2 answers, the positive and the negative. If I only want the positive, they'll have just a positive or no sign in front. If I want the negative, there'll be a negative sign in front. If I want both, I'll have the plus and minus. Okay, remember, you cannot take the even root of a negative number. It's not in the real number system. We're not going into the imaginaries or the complex right now. Okay, so we would square roots, cube roots, and again, for variables, it's like how many groups of that index do we have? Okay, keep that in mind. All right, let me know if you have any questions, guys. Please stay safe out there, and I'll talk to you again real soon.